I've got my hands on a rather cool toy to review from Element 14 for a road test. The Maxrefdes 143 DeepCover Embedded Security and IoT. There's a Maxim integrated, a microcontroller, an ESP8266 to actually go and talk over Wi-Fi, some secure protocol chips that actually do a SHA-256, I believe, right on board. Let's start with this box and see what we've got in here. We've got a getting started guide as a nice clear, crystal clear picture of what we're going to be seeing. Okay, so we have the mbed board. That's going to be your main event. Okay, according to the guide, you've got a bunch of LEDs for indicators, HDK. Okay, so that was the hardware development kit and some other dev part. We've got these connectors here, which I think are supposed to be Arduino Shield compatible, including the weird pitch here. You've got a little bit of prototyping area here, where some of these I think are coming straight off of those pins, so you know we could maybe do stuff around there. And they're through plated, so we may be able to get away with just poking stuff in. So reference designs, okay, and a reference design sensor to plug in. So what have we got here? Oh, here we go. So that's obviously an ESP8266 and ESP01 module, and we've seen those. Protected sensor node using some kind of authentication. The display, okay, so these are indicators, reset, provision, invalidate, okay. So we got these Arduino style connectors on the back. So let's get a closer look at what we have. The Max32600, which is going to be what our ARM embed. Next to it, we've got Polyfuse or something, would be my guess. The LC541A. This is a buffer driver chip. So Max32550. So this is the smaller chip in the upper corner of it. This is actually the hardware development kit section. This is what makes the mbed board work with the mbed development kit. So this is where that other USB bus that is being used to program the device is running. It's a micro SD test pad things that look like jumpers, so you could perhaps bridge those for some other functionality. And there's this very tiny silk screening here. A layout. Oh, we have a layout. Okay, this is great. This documentation, I mean, this is absolutely beautiful. So we've got schematics, we've got the bill of materials. I think if you wanted a redesign based around something you've kind of tested and built here using some of these parts, you've got enough information here to design your own board where you'd only maybe keep what you wanted. So any of these devices I was pondering about in front of the microscope, it's all right here. So we go X4, what is that? That's actually some kind of crystal, right? Crystal. This is fantastic documentation. I'm really impressed with this from Maxim. The Maxim Rev Design 143 board, DS2465. DeepCover Secure Authenticator. This Max66242. So it's a transponder, got an RF I2C case. So this is your SHA-256 engine for generating secure part. Antenna. So this could actually be based upon perhaps an RFID where Vout is coming from the coupling based upon this acting as an inductor to drive this small device. So you can actually have a device that does a bit more than just authenticate here. These are looking like pull-ups. So there's I2C, PIO, okay, with it, well, that's an interrupt. So an interrupt to wake up the slave, do some quick communication here, harvest powered, so it is based on the inductor. Maybe I can look at using this. I have an RFID reader. I don't know if it's the right frequency, so we'll have to look at what this is all about here and whether I could use the Arduino device I had for this to drive it. So this is your other board. That's your light sensor. 7505. Temperature sensor. 2815. That's the DS28E15, the authenticator. So this authenticator talks to one of the chips on this other device to say, I am the right device. So we've seen these devices now. We found the DS2465 and we found these parts on the other device. Now we couldn't see the MAX4409 marking because we could just see the light sensor itself. What I can't see here, this 66242. So we can actually figure out some of these parts. We have here a bill of materials for that board. We've got the switches, we've got, this will be, so level translating GPIO and LED drivers. I think that maybe that's hidden right under our LCD. Here's the DeepCover chip we saw. There's the one wire master. There's the sensors on the other board. And of course, the ESP01 board. There's our LCD display, New Haven display. And let's see what happens when we plug it in. Well, we have live, so we've got a light on the ESP. Board is definitely alive. The laptop has done something. We've got boards there, so it knows which board I've got. Excellent. This one we've added to our account, so we've got this there. Wellness measurement microcontroller. So that's the microcontroller. Okay, so we show the connections. So these are all the Arduino style connections. Then we've got a bunch of other, so this is going to be your SPI bus and programming, so on. What these LEDs are doing. Advanced analog connections. Okay, that is pretty cool there. I'm sure at some point we may get deeper into that, probably not in this initial review. So there are far more connectors obviously than the few that you get from the standard Arduino. Okay, we're going to the features. So integrated AFE enables precision wellness instruments with minimal discretes. Okay, so they mean you don't need a lot of extra components around that. 16-bit ADC, sweet. So lots of analogs, op amps, low power comparators, analog switches. Trust protection unit for end-to-end security. Would it be a TPU? Is that what we call it? USB device interface. Okay, dev for device. Fair enough. LCD controller. Timers. DMA. Real-time clock. SPI masters. 2 UARTs. I2C masters. 1 slave. So it can be a device or it can be the master of a set of devices. Up to 64 GPIO pins. That's amazing. External interrupt. Wake from low power. Pulse train engine with 8 digital output. Is that a PWM output system? Got all the references. Getting started. Aha. Open mbed compiler. Haha, look at this. Okay, right. Now this is happy days. Okay, and this is us maybe getting to what was supposed to be my initial setup. So we've got a template here. I suppose it's going to be a little bit like our Arduino examples menu. And we're going to get an LED blinky, which was the first example I wanted to get at. So let's see if we can get the LED blinky. So we got a main CPP. Let's go in there. Digital out LED 1. So I've not done mbed, and that's very simple. I mean, compared with the Arduino. Okay. Main while true, LED equals not LED, weight 0.5. So, okay, right. So actually, that's an object, right? README. What's in the README? It's a little markdown document. Get blinking working. Please install mbed Clive. Well, okay, we're going to do it straight from this compiler that's online, which means I didn't have to get a dev kit running. Mbed off. Okay, is this the? Ah, right. Okay, and is this documentation? Okay. I kind of see why people like the mbed platform. I've been obviously missing out on this somewhat. If I compile code there, okay. So what I'm expecting is that this file has to be copied. Let's drop this over there. So there's a workflow quite a lot like the workflow for the microbit. And what you can see there, it's blinking away. That was it downloading stuff. So something was going on there. And which LED? 4, 5, 6, 7, and 8. Which LED did we choose? LED 1. Where's LED 1? Highlight this. No definitions found matching LED 1. The digital out is probably, maybe it'll take me to the, yeah, it'll take me to the documentation, show me what that does. This will take me to error in documentation path. Okay. I don't know what's in that mbed.h, but this help here, which tells me how to compile, is fine, but what it doesn't tell me is which pin. So maybe instead of guessing at which pin we're going to put in and where that LED 1 comes from, I'm going to make my own pin number, as in based upon where I think something is connected. Okay, so here's a description of what you might use this device for. So your protected sensor node, you've got your Wi-Fi, the SP8266. That's connected down to the baseboard, which is this mbed DS2465. This is showing you what's connected to what. P21, okay, port 2, 1, 2, 3, red LED. So the first thing I'm going to want to do is maybe let's see if we can say D11. Can we get away with D11 here? Let's compile that. Oh, I love commit and revision, so they might actually have some back end that's actually Git based. Right, it compiled, downloading the software onto it. So we've got an LED here that's lit. I don't see blinking there. That's just on dimly. And I'm assuming, because I'm assuming the blinky would work, that weight is in seconds. So let's see. Float seconds, so we're doing half a second. So we're still not quite getting what we expected. D10 is the other LED. So we're going to see another LED go dim, or have we just not got what we thought we wanted? If I right click, it still just does that and then downloads to here. Okay, I'm getting it to go and run again. Oh, we have a blinking LED. So there it is blinking, running the code that I put there. To build the web server, I'm going to use a tool called Vagrant, which allows me to build VMs with a few lines of Ruby code that says what's going to be in it. So there's an Ubuntu Trusty 64. It's going to be on my public network, which is actually connected to my real router, so it has a real IP. When we're provisioning it, I'm going to install Apache, PHP. I couldn't actually see any MySQL usage in here, so I'm not going to install that. I don't think we need it. And we'll start the Apache service, and you can see I've actually already run this earlier because it takes a while to run. And I've logged in. The first thing I wanted to do was link the /vagrant folder to HTML via www.html, which means that will be mounting whatever's in this directory over here and serving it up using that /HTML directory. And we can go across and actually see, ta-da! We've got the mbed repository page, which shows a list of files, fair enough, but then it's actually got import into compiler. Takes you straight across to these files inside the compiler we saw earlier where we were doing ILE Blinky. And here you've got the display driver, you've got drivers for each of your chips, so there's your ESP8266. So this is actually pretty much an application all ready to go. Now, while that was actually going, I had a bit more of a look at what it is we've got here. What I kind of expected I was going to be looking at was something that secured my link over Wi-Fi between Wi-Fi and the web server, because I thought this was the largest attack surface. What actually this is about is securing this link here between your controller boards and your sensors, hence the protected sensor node, where I think this and these things authenticate with each other using these master secrets, and a challenge from the web server that if someone has swapped this sensor out for some other thing that has data that pretends to be this sensor but now poisons your valuable data with rubbish or junk, you would know about that here. You can then have it so it'll alert when there are problems and there are conditions, which is a normal thing you expect a sensor to do, but it's only going to come from that sensor and not just something someone else has randomly connected in. This is really, again, really useful in an industrial setting. I don't know that it really has a consumer or home user style thing, because not really sure where you'd want that, but maybe if you had an outdoor sensor and you didn't want that replaced because that was some kind of security concern, this would be useful. Do we just compile? No. So here's where we need to set up the SSID. Web server interface.cpp. Okay, so I've replaced the Wi-Fi and password, SSID and password with my own, which I've stuck in a secrets file out there, so I can still edit this file without perhaps giving away my own secrets. But anyway, let's go and build this, because this looks like this is going to be really easy to build and download. So run this, download it, DeepCover embedded bin, beautiful, and we pull up our embed again. Oh, and look, hold on. So what do we have here? It sprung into life, but something went horribly wrong there. What happened there? Wow, what was that? Let's try and do a reset on it. Well, there's something seriously wrong with that board then. I've got no heat problems. Is it that it's still trying to do various PC communication things? is it that I've got some kind of low power condition? Now, does it say in this quick start guide, okay, it talks about Wi-Fi and SSID, talks about the website, so it may have crashed because actually I've not changed it to go to my website. So that may be why we got some madness, or it may be that we've got a low power condition and I'm just not providing enough power for what this device is requiring, because this is just plugged into my laptop USB, and maybe I need to go and plug this into a big power brick to actually make it run, or I don't know, an external port. This 18, where was that? That was it. This one here. So let's presume we can just drop an IP address. I mean, normally it's whether it works the other way, right? Okay, and we're still on port 80. It's still going to be post PHP. Compile. Okay, we're getting major weirdness on here now. Error, initialization error, check Wi-Fi. Okay, I didn't realize this was a multicolor LED here actually. That is pretty cool. I'm gonna go and download that. It's actually failed to download. We're not getting our blinkies again this time. Okay, let's disconnect this device for a second. Have we got any temperature issues? No temperature issues. Okay, registered that it's there, and it's gone again. Oh no, here we are. Right, let's copy that file over again. And the LED at the back is not blinking. So my next question is could this be a low power condition? Could be that it needs to pull more than my the meager USB port on my PC is willing to give up, especially when you've got a Wi-Fi device here. Don't know what these take. There's multiple LEDs on the board here. There's the LED backlight for this, which if it's tried to operate, maybe also quite, high on the juice it wants to pull. Yeah, I'm not sure about this. So what I could do is upload the code with the shield disconnected and then start it with the code on there. Now, what does it recommend here? No, this is stuck because that's stuck. Things are becoming unhinged here. Yeah, look, it's not actually there. Okay, let's disconnect that. Go back to checking here. We load the firmware, compiled it, put it in there. So they're actually suggesting put the code on, then add the board on, and power it through the device USB as opposed to... you see, this is what comes out of not reading the manual. Okay, let's try this way. Let's drag this software back over. I mean, maybe if I plug that into the device thing, we're going to get better behavior and we're going to get some display on here, but it will probably still fail to do the Wi-Fi, and it'll still fail to connect to the web server because it's still got the wrong details, because what we're trying to flash over there is the right details for the right web server. And again, I mean, this is not going to get there. The driver itself is locked up at this point, so that's a bit of a... may require some other doctoring. Okay, but we'll try and see if we can get what was already on there. Oh, that's not too toasty. That's okay. All right. There's probably some debugging. I'm not going to go into that right now inside this video. This is supposed to be just a review, and I think a longer debug session we can do later. So I've plugged in the dev board port as was recommended, and I'm going to try and just put this straight in the PC like that, so we're powering it that way. What are we getting? Well, what we're getting is not good. It's well inserted, it's not half inserted. That's well inserted. Again, there's no hot components and nothing is shorted anywhere. Try hitting the reset button. Or has it partially flashed that code that we tried to flash on earlier and left things in a not quite state? Okay. Should we go? I'm going to go back to Blinky. It's a much simpler thing, and I think I've still got my Blinky code. So perhaps I can... Okay, we got Blinky back on there. Now we've got Blinky back on there, and we can hit reset. This should now be a happy bunny again. Assuming the other code was the cause of the strangeness. And we got this fail.txt again. Timeouts. Oh, watchdog timers? Something of that style. Grab this DeepCover embedded bin, stick it on here, and it is flashing. Sorry, you can't see my screen. Okay, now it's rebooted, woken up, re-registered. Okay, let's disconnect it and let's reconnect this. It looks like you cannot leave this on while flashing because maybe there is just a current problem. Okay, and we turn that on. Initialize controller. Is that click just me holding things? Hit provision to begin. Write down a session ID for later. Okay, sure. And now it says, after successful network connection, shows the unique ID, press the provision button to continue. Okay, let's do that then. Insert sensor node. Well, the sensor node is already inserted, so we press provision, and I presume this is when it's going to go and start setting up. Sensor node needs provision. Okay, let's do that. It's doing it now, and okay, so I love that this is an RGB backlight. So if I put my finger on it, you can see the temperature, and there's obviously a temperature monitor, so when it gets too high, we get the red light. In this mode, the controller continuously authenticates and takes temperature and filter life measurements from the sensor node. Okay, so if I disconnected the sensor node, I wouldn't get silly values here. I should get node not present, something? What do I get? Yeah, authenticates and takes temperature. So, filter alarm if the temperature drops to, filter life drops to 20%, and if, okay. But so what's going on here? So if I reconnect it, do I just get no updates until then? Yeah, what's going on here? Or has the app crashed? Let's just reset in case the app has in some way timed out or crashed. Initializing. Provision to begin. And if I unplug this, it's still saying 0. I've unplugged the sensor. So where's my authentication? I've got what looks like they've got filter and temperature alarms, but where has it gone? Your provisioned authenticated sensor is missing. Because I'd be expecting a nice big red alarm bell here saying, it's not there. Maybe my expectations are wrong here. Okay. So the current filter life is the lowest filter life ever observed by. Okay, a filter life if it drops. So these levels configured by editing the structure. Okay, so you can edit the sensors. Sensor node can be provisioned with an invalid secret, so it causes it not to be. So, okay. So we put in the sensor node again, and so press and hold the provision button till it says what? Press and hold, invalidate. Oh, you got to press and hold provision, and then press and hold invalidate. And then release provision, release invalidate. Sensor node not authentic. Okay, so we managed to tell it this sensor node is not authentic. Cool. And maybe I could have two sensor nodes, and I could have one that I've made authentic and one I've made not authentic. Okay, right. So that's the invalidated controller. Okay, so if I press it again, it goes to normal operation using a valid secret. Yeah. Valid secret hash data sent to the web server. Okay, sensor node not authentic, so we can go provision. Yeah, okay, we're back to that. A web-based user interface used by all the shields is posted with the demo. Once it's posted data to the website, a log's created for it. clear log. So the first thing we need to do is select the sensor ID. Well, this here, oh, there it is. Okay, so we've got invalid message, we've got things from the Mac it doesn't like the so message and all of node authentication. Last reading. Mac this, expected Mac this. What is all this? Is that coming from this? Okay, if I clear the log with the device unplugged, plug this in, we'll wait for initialize, and we'll do our little provision dance again. Okay, we're connected. We've got a filter life and chill attempt, and we're back to getting this invalid message. I think this requires a little more reading. Sensor data, temperature, filter life. Well, we've never seen temperature and filter life. We are only seeing these invalid messages. Why are we seeing that? Hardware error, sensor node not authentic. Well, we didn't see a hardware error or anything like that. We didn't see that earlier. But we have got a MAC that is changing. What is this MAC? Is that a MAC? That's not a MAC address. It's too long. So what is this? Is this... Hold on. Let's go read back a little bit further again. No, this is not telling us how this is working. Is this your master slave? So, okay, so there's an application note probably to read to figure out what is going on with this master slave authentication. And is it this master slave authentication that is in some way failing here? Event type invalid message. So let's go over to where I've got that code here, and we'll search for invalid message. Hopefully it's receive message HTML strong. So data is not authentic or verified. Okay, so we've got if Mac calculated Mac, this is calculate the SHA-256. So the SHA-256 is in some way out of sync. Invalid sensor, sensor data. When are we calculating this Mac? When do we first start calculating? Okay. Ooh. It calculates the expected SHA-256 Is this to do with resetting the device within the lifetime it's been connected to this website and it getting out of sync in some way? I mean, it's not like we've got some kind of off by one where it is just one later. These are all wrong. Is there some way in which could this be some kind of strange endianness issue? I think we want to dig a little bit into what's in this packet structure. What are we sending? So set HTTP post, secret. Okay, you've got a secret. You've got ESP8266. We're doing a get a post with this Mac. So SHA-256 Mac coproc, which is your coprocessor. Okay. Unfortunately, this was me trying to get to the app note, which is a little bit disconcerting, so we may have to try that again. Okay, so I think there's a large debugging session to be had at some point with this. I did say I'm not going to get into debugging this right now. For the most part, I can see this is working. I can see it's definitely reached Wi-Fi. It's on my network. It's tried to reach this server. It's sending something that doesn't quite make sense to this server. So there's a debugging thing to be had there. And there's going to be obviously some fun playing with the fact you've got the LEDs and you've got some other interesting things with this little board here to play with. as an overall demonstration board, first of the mbed, this is a fun kit. Obviously, you know, you've got these different bits to play with. As a demonstration of this authentication technology, the DeepCover embedded security, it seems like there is authentication between the server and this device to make sure it's the same device, and that's possibly what's not working here, or has gotten out of sync somehow. So that must be authentication between the server and these authentication chips here, and what the server's then expecting next, which maybe is answering the where's the rest of the security. You know, it's not just the security on the device. There is, because of this Mac here it's going between there. Again, maybe there's something I'm missing in this app note that I can't read. And I mean, the fact that you can go and open the code straight in this mbed compiler, and that means I can go and look at the code and get my head around what it's doing, how it's doing it. Here's your HTTP post construction. Okay, yeah, okay. So there's definitely a lot of learning to be had. You know, you can I suppose inspect this and pull this apart and find out more. And you've definitely got some interesting devices to play with anyway. This is a board to learn about potential solutions with. So you'd be looking at some of those component sets when you were going to build something that was a solution. And you'd build your own code. You wouldn't just take the reference code. Yeah, I think this is something fun to play with, interesting to learn about these protocols and how they secure things. And for me, it's been a learning experience because I really didn't know about this board. I think that is enough for this video. Thank you for watching. I hope you've got a few ideas from that, and I hope, you know, I mean, I think this is a little bit exciting. I'm somewhat excited about, I'm somewhat excited about the fact that that's gotten hot. Is that being overvolted somewhere? I mean, it's not. I was about to say, I'm somewhat excited about playing with the mbed because I didn't really realise, having not spent a lot of time with it, because I spent a lot of time with Pis and Arduinos and ESPs, and you know, AVRs in general, that the mbed was actually a really nice environment, that web-based environment to develop on. And it's obviously influenced where the microbit has come from. It's web-based environment where you drag and drop a file, which is mbed based as well. Yeah, I'd not really played with that before, so I'm impressed by that. I'm excited by what I can do with this. I'm a bit worried about the temperature of that, so I'm going to unplug that. Anyway, good night and goodbye. I hope you've enjoyed the review. See you.